Okay. What are we doing right now? We're still in 3.2. We have to finish the two activities. So let me share my screen. And someone please take a screenshot of this activity. You guys can all see that. Is Alex here? Alex, you take a screenshot, please. There we go. Oh no, that's not Alex. Okay, either write down this question or there you go. Thanks, Alex. Okay, let's do some breakout rooms. And oh, is the TA here? I can assign you as admin. No? I don't know. Okay, let's do breakout rooms. We'll come back in like 10 or 15 minutes and take this up. Wait, sorry, give me 1 second. Okay, there we go. Okay, we'll see you in 10 or 15. All right, welcome back. So this was the first question, was to take this expression, this sentence, and put it into using mathematical syntax, using symbols. So first of all, do we think this statement is true? Is there no largest negative number? Yeah, that is true. So how do we write this in terms of symbols? Okay, good. So this is very similar to one of the problems in the book. It's on page 57. So if you look at that example, that should guide you. But the key step is you want to start by taking the negation of this thing, because the negation will be easier or more straightforward to write with symbols. So the negation is that there is a largest negative number. Right? The negation is just the opposite of the original. Okay, so this still isn't in math, in math syntax. So maybe, what does it mean to be a largest negative number? It means that if you give me any other negative number, I'm bigger than it, right? The largest negative number will be bigger than all other negative numbers. So this is saying that there is a number, a negative number x, such that for all negative y, what is it? What's the relationship between x and y?
X is greater than y.
Perfect, thank you. Okay, so this is much closer to being a full mathematically syntaxed sentence.
Or why did you write greater than or equal to and not just greater than?
I was about to ask that.
Yeah, I guess it could be greater than if it's largest.
It's the largest, right? So.
Well, because it'll be greater than or equal to itself, because x is negative.
Okay.
So it has to be, it's greater than or equal to itself, right?
Yeah, okay.
So that's really just the one case.
Okay.
Yeah, exactly, good. Okay, so we're pretty close. You see that here's a there is, here's a for all. We just gotta turn this into, use the quantifiers. So this is the same thing as saying that there exists an x less than 0, such that for all y less than 0, x is bigger than or equal to y. There's a nice math syntax sentence, phrasing of the not p. So p is just the same as not there exists x less than 0, for all y less than 0, x is bigger than or equal to y. So that's a good enough answer. Next week, we're going to learn how to put the negation inside of statements, how the negation affects quantifiers. But for now, this is an acceptable answer. Cool? Any questions about that?
I have a question.
Sure.
In 137, we learned that the such that symbol is the colon.
Okay.
Or a straight line down. Is that okay if we use that format here, or should we just assume that there is a such that?
That's a good question. I think it would be okay either way. The notes, though, don't. So
The notes
yeah, the notes don't really use that. They just go straight from there exists to the statement.
So they go there exists an x such that which is less than 0
Yeah,
such
as soon as you
all.
have a there exists, it's understood that the next word is such that.
Okay.
Yeah, but you could if you wanted to. I don't think there's anything wrong with that.
Well, I'm just saying it because it helps me out as well, right? So
Okay.
yeah.
I think either way. If this is a negation, someone asks what's the symbol? This is the symbol for negation. It means not. Cool. Okay. That's activity 1. I'm going to erase this. Activity 2 was which of the following are true. Let me just write them down. So the first one was for all x, there exists a y, x squared equals y. Is this true or is this false?
It's true.
It's true, right? If you give me any x, what can I let y be?
X squared.
Yeah, if you just let y be x squared, then no matter what x you give me, y is equal to x squared. So this is true. Get it? Is that okay? The next one was for all y, there exists an x such that x squared equals y. So this is saying that if you give me any y, can I find an x so that x squared equals y? What do you think? Is this true? Nice. Okay, most people seem to. Never mind.
Sure.
Oh,
I thought he was saying that for all y's there is one x that x squared equals y.
there just is an x. It doesn't have to be 1, but there is an x.
So like for every y, I like say I have my y, there's every y, there's gonna be a corresponding x.
Can you find an x?
Yeah, okay.
So what should x be?
X. What do you mean?
For any y, I want to find an x so that x squared equals y. What should I set x to be? Yeah, nice, Ali. Square root of y. Good. So this is true.
Yeah,
Good?
yeah.
Ooh, what if y is negative? That's a very good point. That's a very good point. Does this question say if they're negative or positive?
Says all real numbers, I think.
So, nice, good catch. So this is wrong. This is true.
False.
Nicely done. Only for y greater than or equal to 0. So actually, it's false. It's false if y is less than 0, right? There's no x such that x squared will equal y because x squared is always non-negative. So good catch. So the answer is actually false. So this statement here, if y was bigger than or equal to 0, then we could say this. So this is for any, one second. This is for any y bigger than or equal to 0. So very good call. You can't do it if it's negative. Okay, what about the last one? The last one was there exists an x such that for all y, x squared equals y. No, it's a very different thing. The there exists comes first. So this is saying that I can find an x so that no matter what y you give me, x squared equals y. Is that why is it false?
Because there exists means at least one, right? So it's basically saying there is at least one x that for all y's x squared is.
Yeah. So, but can you give a concrete example? This implies that
Okay.
an x.
That it's basically let y equal like 8,
Okay.
and then let x equal 2. That's false then.
Okay. Yeah. You got it. So x squared. This says that there exists an x such that x squared equals 0, and x squared equals 1. That's impossible. Does that make sense?
Okay.
I mean, what you said was also correct.
Yeah.
I mean, any two numbers you give, you can't have x squared equals both of them unless they're equal.
Yours is simpler though, so.
So this is false because, yeah, you can't find an x that squares to every number. Which part? The statement is saying that I can find an x so that its square is equal to any other number. That's not true because x squared can't equal 0 and 1 at the same time. Okay, I think, got it? Nice. No, it can't. Okay, let's move on. So we're now going to start talking about 3.3, truth and falseness. And we're going to start talking about truth tables. I don't think truth tables are actually done fully in this chapter, but I think it's still worth it to talk about a little bit. So let's say you have two statements. Before I do the next clicker question, let me just remind you of the key facts of this chapter. You have two statements, P and Q. The question is, depending on the truth or falseness of P and Q, when is the statement P and Q true? And when is the statement P or Q true? So, okay, if I have a statement P, it's either true or it's false, right? One of those things has to happen. I mean, given two statements P or Q, either they're both true, P is true and Q is false, P is false and Q is true, or they're both false. One of these four cases has to happen, right? Given any statements P or Q, they fall into one of these four cases. But the question now is, what is the truth value of P and Q? So you guys should all know this. When is P and Q true?
Both have to
Yeah,
be
they
true.
both, right? If you have a statement about, if you have two statements anded together, they both have to be true. So this is only true if they're both true. Otherwise, it's always false. Nice. What about P or Q?
One has to be true.
Right. So for us, exactly, good.
Can both be true as well? I know.
Yeah, they can both be true. If you have two statements and they're both true, then if you just put an or between them, it's still going to be true.
Okay.
Right? Does that make sense, sort of?
Yeah,
Okay. Those are the main ones. Okay, maybe let's do the main one more. And this one's a little subtle. I don't want to spend too long talking about this one. But what about P implies Q?
That's if then.
Yeah, this is an if-then statement. So what is the truth? When is this statement true and when is this statement false?
They're both true.
It's true.
Or when they're both false.
If P is true and Q is true, then it's true. If P is true and Q is false, then the statement is false. So P implies Q. Think of it as saying if P is true, I promise you that Q is true. So if Q is false, then the whole statement is false. And now this is a really subtle point that if P is true, if P is false, the whole implication is true. And this often trips out students, and in fact, it is a very confusing thing. If you want, you can just take it as a definition. If the hypothesis is false, then the statement isn't really saying anything. Yeah, right. P implies Q is a causal relationship. Like for example, oh man, I shouldn't have. Now I got to think of something. Like okay, if you get above 90%, then I'll give you an A. Okay, that's my promise to you. If you get above 90%, I will give you an A. If you get above 90 and I don't give you an A, I've lied. I've broken my promise. It's false, right? But if you don't get above 90%, and I don't give you an A, the statement is still true, right? You didn't get a 90%, but that doesn't mean that my statement is false. My statement is still true. So it's a very confusing thing. Yeah, basically, I'll just always give you an A.
I'm okay with an A.
No, so it is a subtle point, but let's move on. Just accept these two sort of tricky little, what's the word, like subtle points.
Can I try explaining it?
Sure, yeah, go ahead.
Because in 137, our prof actually went in depth with this just so because like the next like 2 weeks was built on this.
Okay.
And basically when both are false, the prof used the example of if it's raining, then it's cloudy.
Okay.
So if it's not raining, then it's not cloudy. So that means, right?
Mm-hmm. So if they're both false.
Yeah, right?
The statement is still true.
Yeah, exactly.
Okay. Yeah, so it is confusing, and I definitely encourage you to think about it some more. There's lots of examples in the notes which illustrate this point. But let's move on, and you should, for the rest of this course, this truth table is like fundamental. You have to know when these things are true or false, when compound statements are true and false. So let's do our first clicker question. And
in this course, do we do exclusive ors and exclusive ands?
no, it's inclusive. If one of them is true.
No, I mean, but there's like a lot. There's other logical operators like exclusive ors. And
Oh no, we won't talk about that.
Okay.
This is the only or and you'll need to know.
Okay.
Okay. So yeah, this is really the key truth table.
Okay.
Do I have this here? Oops. Okay. Uh-oh. Did I just show you the answer? Anyway, here's your first clicker question. Which of the statements below is false? So they've given you 3 statements, P, Q, and R. Which of these things is false?
So what's the definition of a prime number again?
Someone want to try and answer that? What's the definition of a prime number?
It's been a while.
Which only divides by 1 and itself.
That's right. The only divisors of it are 1 in itself. So
like evenly, right?
Sorry?
Evenly, right? Like it has to produce a whole number?
Yeah, they're integers.
Okay.
Positive integers, really. So like
Okay.
7, the only divisors of 7 are 1 and 7. So it's prime. But the 8 has, or maybe 6 has divisors 3 and 2.
All right.
So 8 has divisor 2. So those things aren't prime.
Yeah, okay.
I'll talk a lot about prime numbers a little bit later.
Okay. Thank you.
No problem. Okay, let's go get your votes in. Only 30% of you have voted. Nice. You guys seem to be crushing it. Okay, I'll give you 10 more seconds. Okay, I'm going to close it now. Okay, now the votes pour in. Okay, 3, 2, 0. Nice. So most people got it. Let's take it up really quickly. I'm going to move fast through this one. Oh, come on. Okay, so P17, what was it? 17 is a prime number? Is that true? 17 is definitely a true statement.
It is a prime number.
17 is true. What about Q equals, is 1.234 a rational number?
No.
It is a rational number.
It is.
So Q is false.
That's what I was trying to say, like the statement is false. I'm sorry.
Yeah, exactly. And R, well, this is true also, right? X squared is always bigger than or equal to 0. So maybe I won't do all of these, but so the first one was P or Q and R. So for this to be true, we just need one of these things to be true. This is true. So we don't even need to look at the thing on the right, even though the thing on the right is false, right? This whole thing is false. But the whole thing is true because one of the things in the or is true. Cool? So this was A. So the whole thing is true. Maybe what should I just do B also? B was P or Q and R. So this is an and statement. So for an and statement to be true, we need both of the things to be true. So this is true. P is true. So this whole thing is true. So both the things on the side of the and are true. You guys get that?
Yeah.
And then C was false because it was not P. So not P. Not P is false. Not Q is true. Not R is false, right? It's just the opposite. So C was not P or Q and R. And R is true, but not P, this is false. And Q is also false. So this whole thing is false. So one of the conditions on the and is false. So the whole thing is false. Okay, maybe I'll stop there. D was also true. Any questions about that? Oh.
Mathematicians get lazy, so you have to work hard.
Cool. All right, let's do our next one. Moving on. So yeah, the answer was C. C is false. Which of the implications is true? So here's four. Uh-oh. Okay, here's four implications. Which of them is true?
Wait, are you trying to say that x is all real numbers?
Yeah, it says that at the top. Which of the following implications is true for all real x?
Yeah, okay.
This one is not does not appear to be going so well. Maybe I shouldn't have said that. Okay, 50%, more than 50% have voted. I'll give you another 20 seconds. I don't know what's going on. Yes, this is a coffee. QE.
Oh crap! I pressed one.
All right, guys, I'm gonna end the poll now. Yikes. So the answer, I believe, is not C. I think the second highest answer is right. The D, yeah, the D gang. Yeah, it's a D. So why is D true? Remember that an implication is true if the hypothesis is false. Okay, so let's do it.
Yeah, they're right. True. Two wrongs do make a right.
Yeah, I guess that's one way of thinking about it. X less than 0 implies x less than -1. This is an implication. This thing is false. So right away, you can say the whole statement is true. Right? Because the hypothesis is false, right? Remember that, I won't write the truth table again. But if the hypothesis of an if-then statement is false, the whole thing is true. For all the other options, the hypothesis is true or could be true, and the conclusion is wrong in all of them. Right? In A, if x equals 1, then x isn't less than 0. X squared isn't always bigger than or equal to x. Right? Are there other questions? Is there one you want me to talk about? Can you explain C? C is that x is greater than or equal to 0 implies x squared is bigger than or equal to x. Yeah, exactly, decimals. This is false. So if you suppose x squared is equal to greater than or equal to 0, well, let x equal a half. Well, then x squared is less than x. So the hypothesis is true, but the conclusion is false. So it's false. The answer was D, because the hypothesis in D is false. Yeah, good. Any other ones? Is that okay? Yeah, okay, good. Okay, let's move on. One more clicker question. I'm pretty sure the answer is D. There you go. Okay, consider this statement. For all x and s, x's and z, the absolute value of x minus 1 is 2. For what s does the statement become true? There we go.
Hey,
There we go. Okay, wow, time flies. This is the last clicker question. I think we can finish today. Maybe I won't do breakout rooms for the last activity. I'll just give you a few minutes to work on it. Actually, I've been meaning to do a poll to ask you guys how you feel about the breakout rooms. I would love to hear your feedback on it. If you like them or don't like them. Oops, did I just close? Uh-oh. Did I just end the poll? Oh no, sorry. Yeah, is that a popular opinion?
I feel like they would be better if you like if you made less of them so the prof could go to each one,
Okay, that's good feedback.
right?
Yeah, but as they get bigger, it's harder to collaborate amongst each other.
Well, most people just like if there's like a room of 5 people, I think 2 people are talking, that's it.
Yeah.
That is true. People will be having their mics muted.
Okay. Well, all right. Maybe we'll do things a little bit differently moving forward. Yeah, I get it.
I hate the fact that we're test subjects for this.
I don't know. I don't think that's true. Okay, that's good feedback. I'm happy I asked. All right, let's end this poll. 90% of you have voted. What's the answer? Okay, most people are getting it, I think. Maybe I won't take this one up in too great of detail. But for what integers does x minus 1 equal 2? The absolute value of x minus 1 equal 2? X equals 3 and x equals -1, right? So maybe I won't write anything down for this question, but A can't be right because 0 is in there, right? And 0 minus 1 is equal to -1. So that doesn't equal 2. B, I'm pretty sure, is the answer because the only integer in option B is -1, right?
Yeah.
B has 2 in it, and 2 minus 1 is 1, so that's not right. And D has 0 in it, for example, and 1. So the only option is B. So nice, most people got that one. Are there you want me to say anything more about that, or is that all right?
I have a question about the quiz next week.
Wait, sorry, 1 second though. So yeah, that's right, the rationals aren't part of the integers, but you're only looking at the integers in these intervals. Like in the first one, the only integer is 0, 1, 2, 3. Right? We don't care about the rational numbers. In the second one, the only integer is -1. In the third one, the only integers are 2 and 3, and in the last one, it's 0, 1, and 2. You see what I'm saying?
Yes.
Yeah, you're only testing the integers. Yeah, that's what the question's asking. Right, it says for all x and z. Perfect. Okay, good. Okay, was there another question? Just maybe a quick one.
My question about the quiz was, would it be possible if you guys sent us the quiz link like 5 minutes before the quiz started? Just because of like people could like if they're having like tech issues, they could probably fix them and stuff.
I hear you. I think that's a question for Marina, the course coordinator.
All right.
So yeah, ask her. You can post it on Piazza if you want. The quiz is on up to functions, I believe. Problem.
So is it only the like the 2 point whatever questions?
Yeah, up to 2.3. Yeah, there isn't any.
There's no
like fields is on it. Yeah.
Fields is on it. Damn it.
Is the triangle inequality on it as well?
Well, that was from before. So yeah, everything from before is also on it.
Oh, so everything.
Oh, like AGM and everything.
Yeah, it's cumulative. Math is always cumulative. I mean, you'll be asked directly of things from problem set C or whatever it was on, 2.1, 2.2, 2.3, but you'll still have to know the stuff from before, right? Like we used AGM last class. We used, I don't know, we've used stuff about sets since like after we learned about sets, right? Anyway, we only have 8 minutes, so I would like to finish 3.3 if possible. So here, can you guys see my screen still? Yeah, okay, so here's your activity. There's 2 questions. Someone could post a screenshot, that'd be awesome. All right, I think we only have 8 minutes. Let's just work on it on your own for a few, or for 5 minutes, and then we can take it up. I'm gonna stop the recording while you guys work on your own though. Just so that it's not. Cool, okay, so the question was, P is if N is even, then N is the sum of 2 odd integers. Okay, so they let E be the set of even numbers and they let O be the set of odd numbers. So does everyone agree that the statement is, it's saying for all even numbers, so for all X in E, maybe E is a bad choice. But for all X in E, what? There's 2 odd integers, right? There exists, that's why the E is a bad choice. For all E in E, there exists, I don't know what to call them, Y, and there exists
Z.
Yeah, there exists Y in O. Nice, good. There exists Z in O, such that what?
So Y plus Z equals X.
Perfect. There you go. That's the statement in math. Okay, now to prove it, so let X be an E. That means that it's even. So I'm just going to go quick because we're out of time. What does it mean to be even?
2 odds equal to an even.
Yeah, it's equal to 2 times something. For some integer, right? That's what it means to be even, that you're 2 times something. So what are 2 odd integers that add to 2n? Can someone tell me what are 2 odd integers? N, is n odd? Why is n odd? 3 plus 5. But 2n is n is arbitrary. There you go, that's what I'm looking for. 2n plus 1 and minus 1. Then these things are odd, right? 2n plus 1 is always odd, and negative 1 is odd.
Aren't we supposed to use a arbitrary number for Z as well?
You don't. It doesn't have to be. It's there exists. So you have to just find 1.
Oh, okay, okay.
So Y is an example of an odd number, and negative 1 is an example of an odd number.
Okay.
Cool?
Yeah.
Okay, I'm going to erase this. And then I'm going to quickly do activity 2. And then we're done 3.3. Sorry to rush it, but seems like you guys are all getting it. Nice. Okay. No, I mean, you can. There's nothing stopping you, but there's a symbol for that. So if they ask you to do it in math syntax, then you should use the quantifier symbols. Okay, and then the statement is S is equal to P implies Q or R and P. And they told you that this S is false. So if S is false, the question is, what does that mean about P, Q, and R? Are they true or false?
Q and R are false. P is
Remember,
true.
so this is an OR statement, right? So the only way an OR statement is false is if both things on the sides of the OR are false. So this says that P implies Q is false, and R and P is false. Does that make sense? And how, there's only one way that P implies Q can be false. How can P implies Q be false?
When Q is false.
And what else? Yeah, perfect. Thus P is true and Q is false, right? This follows from this. Since this follows from, it really follows from this. P implies Q is false, implies that P is true and Q is false. And now R implies P is false. This says that one of those 2 things is false. But we know that P is true. So this says that R is false. And that's since P is true. Does that make sense? Are there any questions, quick questions about that? So in summary, we have P is true, Q is false, R is false. Nice. Well, I'm happy to hear that. We're going to continue working with logic all of next week. All right, guys, I think that's it. Any last questions? Okay.
Can I quickly, for the first question before,
I'm going to pause this now.